For the great enemy of the truth is very often not the lie, deliberate, contrived, and dishonest, but the myth, persistent, persuasive, and unrealistic. Too often we hold fast to the cliches of our forebears. We subject all facts to a prefabricated set of interpretations. We enjoy the comfort of opinion without the discomfort of thought.
Talk to you about the full panel contact. Put your saddle on the horse. Put your right hand underneath the stirrup bar area, which is approximately right here. Slightly hold the saddle in position with your left hand and go very slow. And go through it. Take your rings, of course, off if you have any. And you will feel a lot of contact on top of your hand. Put this hand flat to the horse's back because you have more sensitivity on top of your fingers. And I have a nice even panel contact. Do this on both sides. What would happen if the saddle sits tight here, loose here, tight here? What would happen is that we have excess pressure here and here. It's kind of like your sock is wrinkled up in your shoe. What will happen if we have loose contact in the front, tight in the middle, and loose in the back? The saddle will rock a lot, and all the rider's weight is distributed over one point. The goal of saddle fitting is that we like to have the saddles distribute the rider's point over a large area of 220 square inch.
I don't know. Let's not beat around the bush, Robert. We need a saddle that fits. How are you different from every other Joe out there? That's what we want to know.
Well, let me get my horse and I'll show you.
Now, expert saddle fitters claim that you need to fit the saddle so it fits evenly on the horse's back. Now, to test that theory, we have molded a piece of plastic into a mirror image of this horse's back. Since the plastic is clear, we can actually see that it fits this horse perfectly. Okay, so now what we're going to do is put the plastic to test this idea if an even surface actually does what everybody says it does. So we've got that with a little bit of padding for the horse.
Yeah, Robert,
Okay.
I'm seeing a
Now
lot
you
of
see what's happened here?
red.
You've got a space in the middle here, and then you've got pressure top and bottom. That's called bridging.
Okay.
That's how you get the white hairs on the horse.
But what's interesting is that was the one with equal distribution.
You
So
got it. You got it. That's the issue.
It's not
That's the
working.
issue, that what you've been told for all these years is false.
So it doesn't matter if the saddle weight is evenly distributed because when the rider gets in the saddle, it all changes.
Exactly.
Right? Develop this system?
Yeah.
I'm really shocked that I've been so misled by all the other saddle companies. I mean, not just me, everybody has been misled.
Yeah, I was pretty shocked myself when I found out about it. I mean, I built this thing 10 years ago and started showing it to the saddle makers, and they've been ignoring it.
So you mean to tell me they've known about this for 10 years?
Well, they realized that if they were to use this, what would happen is that people would see that the saddles don't fit and they wouldn't buy the saddles. Very simple problem. So we're in this unusual situation where people are selling defective products, the consumer is not aware of the deception, and it goes on and on and on, and we've actually got a solution, and the saddle industry doesn't want to do anything to help.
No wonder we couldn't find a saddle that fit.
Well, you can see the problem. How are you going to fix it?
Well, what I finally discovered is that, like most things that are solved today, is you apply mathematics one way or another. So what I've done is I basically built a mechanical device that breaks the polyform shape of the horse's back into angles and arcs. And once you have those areas described, you then can write a formula that's capable of changing the effect of the weight of the rider relative to the weight of the horse.
Okay.
So what you just saw is that a saddle that is made to fit evenly unladen bridges. So what you have to do is give it more rock so that when the rider goes into it, you now have an even shape. So once you have that, you can then use the computer system to verify that that's true.